Hello, and welcome to this video on change of coordinates in a polynomial space. We're working with polynomials of degree at -2 in the variable t, and we want to do two things. First, we want to find the change of coordinates matrix from a basis C to a basis B, and then we want to write a polynomial as a linear combination of polynomials in C. Work on the first part of this problem. We get to work with the matrix. The change of coordinates matrix from C to B is denoted by P sub, and then we write C to the right, left arrow, and then B to the left. This matrix is composed of various columns. We write one column per vector in C. We notice that even though we have polynomials, we call those polynomials vectors because we're seeing those polynomials as elements of P2T, which is a vector space. And the first column of this matrix, this change of coordinate matrix, corresponds to the B coordinate vector of 1 minus 7t squared. 1 minus 7t squared can be seen as 1 times 1 plus 0 times t plus negative 7 times t squared. Then the B coordinate vector of 1 minus 7t squared is 1, 0, minus 7. The second column of the matrix corresponds to the B coordinate vector of minus 2 plus t plus 15t squared. The polynomial minus 2 plus t plus 15t squared can be seen as negative 2 times positive 1 plus positive 1 times t plus positive 15 times t squared. Then the second column of the change of coordinates matrix from C to B is negative 2, 1, and 15 as a vector. Finally, the last column of the matrix we're looking for corresponds to the B coordinate vector of 1 plus 6t. We look for weights coming from writing 1 plus 6t as a linear combination of polynomials in B. We have 1 times 1 plus 6 times t plus 0 times t squared. We take the weights 1, 6, and 0. Those weights form the B coordinate vector of 1 plus 6t. That B coordinate vector is the third column of the matrix we're looking for. So here we have 1, 6, and then 0. Okay, so there we have the change of coordinate matrix from C to B. Now, let's write t squared as a linear combination of polynomials in C. We want to see t squared as a combination of 1 minus t, 1 minus 7t squared plus, and minus 2 plus t plus 15t squared, and then 1 plus 6t. To write t squared as a linear combination of polynomials in C, we find weights alpha, beta, and gamma so that t squared can be seen as corresponding linear combination of those three polynomials we have in C. But then those numbers, alpha, beta, and gamma, form a vector. We're thinking of alpha, beta, and gamma as the weights we need to take in order to write t squared as a linear combination of polynomials in C. That coincides with the C coordinates of t squared. And there is a relationship between the C coordinates of t squared and the B coordinates of t squared. From the first part of this problem, what we have is that the B coordinates of t squared come from the B coordinate vector of t squared comes from multiplying the matrix P from C to B by the vector that corresponds to the C coordinate vector of t squared. Then the C coordinate vector of t squared corresponds to the inverse of the matrix multiplied by the B coordinates of t squared. In order to find alpha, beta, and gamma, it's enough to find inverse of the matrix we found in the first part of this problem times the B coordinates of t squared. Now the inverse of that matrix can be found by using many methods. I found it beforehand. The inverse is minus 90, 15, minus 13, minus 42, 7, negative 6, then 7, negative 1, and positive 1. And we multiply that matrix by the coordinates, the B coordinates of t squared. The t squared is 1, 0, 0 as a constant term, 0 as the term in t, and then the coefficient of t squared is 1. That way, we obtain that the C coordinate vector of t squared is negative 13, negative 6, and then positive 1. Meaning that we can write t squared as minus 13 times 1 minus 7t squared minus 6 times minus 2 plus t plus 15t squared, and then plus 1 times 1 plus 6t. Okay. So there we have t squared written in terms of polynomials in C. T squared is written as a linear combination of polynomials in the basis C. Okay, so this is the end of this problem. I hope you enjoyed this video. If you have questions, let me know. Make a comment and I will try to help as soon as possible. Bye-bye.